Hi, my name is Nick Borson, and in this video I'm going to talk about how to use PowerShell to query, to pull data out of XML files using the Select-Xml commandlet. This is part one of a series of, I think, just 2 videos I'm going to make, that I plan to make about working with XML files in PowerShell. So Select-Xml, like I said, is a very convenient way of pulling data or querying for data in XML files. So in this video, I'm going to kind of go over, first of all, what XML is. XML stands for Extensible Markup Language. It is a text-based format for representing data, and that data is hierarchical, so it is sort of a tree-like structure. So I'll go into an example of an XML file and various examples of querying that using the Select-Xml commandlet. The Select-Xml commandlet, you have to specify the input file, which is the input XML, and there's 3 possible ways of doing that. The path parameter would just be a file name, or in other examples I will show how to pass an object that contains the already parsed XML using the XML parameter. The XPath parameter is the query, that describes the data you want to pull out. And the result of this is an object that represents the matching data, and we'll go into that in the examples. So XPath is the core of this. XPath is a simple query language for XML, and an XPath is to, like I said, XML has a tree-like structure, just like a file system has a tree-like structure. So XML is to the tree of XML nodes the same that a regular file path is to the tree of folders and files in your file system. And like a file path, it can have wildcards, but also XPath has other capabilities like predicates and so on. So we'll go into some of that. So in the examples, we'll start with just some, after showing you an example XML file, I'll show you some basic XPath expressions, then talk about sanitizing input. So if you have input that you want to incorporate into your XPath query, making sure that doesn't blow up on you. Then we'll talk about XML namespaces, and finally show a little bit more complicated example with a nested query. So we take the result of an XPath query and use that as input to another XPath query. Before we can really talk about how we process XML using PowerShell, it's important to get some basics about what XML itself is. So XML is a text-based format, file format, or data format that allows you to represent hierarchically structured data. So data can be arranged in a tree-like structure in a way that is human readable and also easy for, there's a lot of tools and so on that can parse XML and make sense of it and read it and write it and so on. So the basic structure of an XML file is we have elements represented by tags, and those elements can be arranged in a tree. So an element can have child elements, and each element can also have attributes. In addition to elements, we can also have text. So the content of an element, the children of an element, can include just plain text as well as other elements. So in this document, we have a hierarchy in which the top level element, the root element, is called bookstore, and that bookstore element contains a series of book elements, and each of those book elements contains series and inventory elements. So you can kind of see that just by looking at the document here. So let's go into a little more detail on the format. So the bookstore element here is represented by a start tag and an end tag. So the start tag is on the first line of the file, the end tag is on the last line of the file. And each of these tags is enclosed in angle brackets, less than and greater than signs. We call those angle brackets. The start tag just has angle brackets around the name. The end tag has a / before the name, and that is what tells us that this is an end tag. So anytime you have a start tag, you have to have a corresponding end tag, and then what's in between is the content of that element, or the nested content, the children of that element. So the first child of the bookstore element, ignoring white space, which does count, but it's not really representing useful data here. The first child element is a book element. So again, we have a start tag this line 2 here is all a start tag for the book element. We have the left angle bracket, then the tag name or the element name book. And in this case, we also have attributes. So we have each of the attributes consists of a name, an equal sign, and then the value of that attribute enclosed in quotation marks. So this book element has title and author and format attributes. And then at the end, we have the closing angle bracket. So this whole thing on line 2 is the start tag for a book element. Then on line 5, we have the corresponding end tag for that book element. So again, we have the left angle bracket slash book. So the slash again at the beginning of the tag name means that this is an end tag. In between the start and end tags, we have child elements for that book element. So first we have the series element and the inventory element, and both of these are empty elements. They don't have any child content, and they also don't have end tags. Instead, what we see is that there is a / before the closing angle bracket. That / at the end of the tag means that this is an empty element. It doesn't require an end tag. It doesn't have any child content. So we have start tags, we have end tags, and we also have empty elements that don't have an end tags, kind of like a start tag and an end tag all in one. And then each tag, or each start tag or empty element can have attributes. And also, as I mentioned before, there can be text. An element contain text as well as other elements, but I don't have that in this example, and it's not used in any of the examples I'm showing here. So that is a quick summary of how XML is represented. One more thing to add is that the formatting here with the white space and each element on its own line is really just to make it more readable. You could have this whole thing all on one line with no white space, and that is in fact how XML files in actual use are often represented, just because I guess it saves space. But to include the white space just makes it easier for us to read and understand. Okay, so we've got a quick overview of what XML is. Let's talk about how to process XML in PowerShell. So the first thing I'm going to talk about is a command called Select-Xml. And this provides a convenient way of querying the contents of an XML file using what is called an XPath expression. So an XPath expression is really very much like a file path. Just like a file path can be used to represent the location of a file or a directory in a tree of folders. So a file system is hierarchical, and XML is also hierarchical. So XML allows you to locate an element or an attribute or a text node in the XML tree. So again, we have this. Looking at this XML file, we have this kind of logical structure where we have the bookstore element at the root of the tree. It contains book elements. Each of those book elements contains series and inventory elements, and each of those elements, or some of those elements, contain attributes. So XPath allows us to kind of walk that tree, traverse that tree in order to find the data we're looking for. So let's suppose that we want to find well, let's say we want to find all the titles in this, all the book titles in this document. So to do so, we can basically give the path of the title attribute of the book element. So the book element is a child of the bookstore element. So if we start at the root, we go for bookstore, then book, and then we get the title attribute. So let's go ahead and go to a terminal window. And I'm going to use the Select-Xml command. And to start with, I have to say, what is the data we're going to query, and the actual XML data. And the way I'll do it for now is to use the path parameter, and this is just the name of the file we're going to process. So we're going to read the data, and then I'm going to give the XPath expression, which is the information we're going to query for. So bookstore. So I start with this. So just like with a file path, we use slashes. In this case, it's always / in XPath. Slashes to separate the nodes of the path. And I'll say bookstore, because that's the root element. And then I'm interested in all the book elements under the bookstore element. And then to refer to an attribute, I use @ and then the attribute name. So this will select all of the title all of the title attributes. Now for each of these, what we get back here is an array of Select-Xml info objects. That's the type of the returned objects. And I know that I can let's say I go ahead and grab this. Let's say I'll assign this to a variable. Do the same query, but assign it to a variable. And if I look at info.getType, we have an array of objects. Okay. And if I look at the first element of that array, info0getType, we see that it is a Select-Xml info. And if I were just to look up the help for Select-Xml info on the web, I would see that it has 3 properties, which are what we see in our table here. There's the node property. The path property is just the file we queried. The pattern property is the pattern or XPath expression that we use to query it. So what we really care about is this node property, which is the actual XML node. In this case, an XML attribute node that we want. So so here, if I say info0 node, then we see and when we get its type, we find that it is an XML attribute. So there's different kinds of XML nodes. The XML node is in .NET. The XML node or system.xml XML node is the base type of all the different types of things that can be in a tree that represents the XML document. This tree of objects that represents an XML document is called the DOM, Document Object Model. And an XML node is just one element of that tree, and specific types of XML nodes include XML document, XML element, XML attribute, XML text, and so on. So in this case, by selecting the at title, what we got back is an XML attribute. And if we say format list, and as for all its properties, we see that it has this pound text property, but what we really kind of want is actually it's interesting. I wonder if I specified pound text in the query, I don't think that's part of XPath. Anyway, we can always refer to its value. An XML attribute has a value property, which is the actual text. So let's put it together. Let's go back to our query. And this time, what I really want is just the text of all those attributes. So, so I'm wrapping the whole thing in quotation marks, and I want the node. I don't want the XML for each of the things I get back. I don't really care about the XML or about the Select-Xml info. I care about its node property. And for the node, which I happen to know is an XML attribute, I care about its value. So if we wrap that whole thing in parentheses and then access the .node.value, we get back the actual titles. And there we see, looking back in here, we have the title attribute of the first book, the title attribute of the second book, on line 6, the title attribute of the third book, and so on. We get all the titles from our XML file as output. So there is a simple usage of Select-Xml to pull data out of a XML file. All right, so back at our XML file, let's take a look at a slightly more complex usage of XPath, and it's going to introduce a new concept, which is predicates. So here I have a script that I wrote, and it does pretty much what we just showed in our terminal window. We have the path of the file we're going to read. We have a title of a particular book we're interested in, and we're going to construct an XML expression that gives us the price for that particular title. So what this introduces is a new concept that I haven't explained before in XPath called predicates. So again, we have our path. So starting with a slash, meaning we're going to start our search at the root of the tree. Then we look for the bookstore element, we look for book elements, and then inside the square brackets we have a predicate. And what this means is we're only going to match book elements in which the title attribute is equal to the string, in this case, the 2 towers. Then this whole thing is one node, but a node that only matches books with that particular title. And then under the books, under that element, we're looking for its child inventory element, and then the price attribute of that inventory element. So again, the title is 2 towers. So let's look at how we expect that to work here. So we're looking at the bookstore element. We then, under that, we look for a child book element that has the title of the 2 towers. So here we'll expect to match this element. And then under that element, we look for an inventory element. So we expect to match the element on line 20, and we're going to get its price attribute. Oops, go back here, get its price attribute. We expect that to be $7.99. So in the script, we output the query, the actual query that we wrote, which is interpolating the title into this string, and then we use our select-XML command, and again we get the node. We access this. So the select-XML command will give us back the array of select-XML info. We'll get the actual XML node, which is an XML attribute, and then we get the value of that node, which is the price, the attribute value. So if we run this script, so test XPath1, then we see that the XPath query, that is the actual string, that's the XPath query string, including the title interpolated into that string, is bookstore books title equals 2 towers, inventory price, and then we see that the result of the select-XML is the actual price that we found in the XML file, which was $7.99 right there. So that is an example of using an XPath expression that includes a predicate. Now let's take a look at another small variation on this. So here's a slight variation on the previous file, previous query. It's really almost exactly the same. The only difference is that previously we had a file name, so path data XML. Here we're taking that file, we're getting its content, and we're storing it in a variable of type XML. I'll get to that in a second. And then down here in our select-XML command, instead of using the path parameter, we're using the XML parameter. So this script is going to behave exactly the same as the previous script. The difference is that the input to the select-XML command, instead of being a file path, is the actual XML tree that we've already read. And the point of this is that you can, first of all, the XML might not be a file at all. You might have constructed it on the fly. But more likely, you've read the XML, but you want to read it. You just want to read it once and parse it once, and then construct this tree, this document object model, this tree of objects. You just want to do all that once and store it in a variable, and then you can do any number of select-XML commands without having to reload and reparse the file every time. So let's take a closer look at lines 2 and 14 here. So line 2, we get the content of the file. So this is where we actually open the file, read it into memory. And then we use that content to initialize a variable, and we give that variable an explicit type, XML, which actually ends up being an XML document. But in PowerShell, this is conveniently just referred to as XML. And what that means is we're casting the content to this type, in which implicitly will actually parse the content, convert it into this tree of objects, and this data variable now is the root object of that tree. So then, when we use the select-XML command, we can just refer to that data using the XML parameter. So instead of using the -path parameter to parse the file during the select-XML command's execution, we use the XML parameter to refer to the already parsed XML data. And this behaves exactly the same as the previous script. So if I say test XPath2 PS1, we get the same exact output. All right, building on that last example, let's say that we don't want to hard code the title. We want the title to be a parameter. Maybe this is user input. You want to have a quick way, a convenient way for the user to say, find books with such and such a title. So we can, let's go ahead and just look a slight variation of that previous script. We'll just make title a parameter, so we can use the param keyword at the start of our script to declare the script parameters. We specify that the parameter is mandatory using this syntax. That means that if the user doesn't specify the parameter on the command line, they'll actually be prompted for it. So we We require this parameter to be specified. It has the type string, and its name is title. So again, we read the XML into memory, parse it, construct this tree, this XML document object model, this tree of XML nodes, which we assign to the data variable. And then here's where we construct our query. So we use the same format as before, but now the title just is a parameter. So we have bookstore book. We are using a predicate to specify we only match book nodes that have the title that was specified. And again, having found such a book, we look for an inventory child element and get its price attribute. And again, we output the query and do the select XML exactly as before. So let's go ahead and run our script. We'll say test XPath 3, and I'm just going to specify the title on the command line, and I will say the 2 towers, same as we had before, and we see that we got the price $7.99 just like we did before. So let's try a different title. Let's say we want to, another one of the books in our inventory or in our book list was Harry Potter and the Sorcerer's Stone. And now we see that we ran into some problems. So let's take a closer look at the output we got here. I have to make that bottom a little bigger. So it's saying that the Harry Potter, this string, this XPath expression, has an invalid token. So this line here. Up above, we saw that this is the XPath query that we output on line 6 of our script. And we see that we have bookstore book at title equals, and then in single quotes, we have Harry Potter and the Sorcerer's Stone. And here we have our problem. We have an apostrophe, which is really the same as a single quotation mark, in the middle of our string. And so it led to this confusion because it thinks that the string ends right here. And so then we have, unexpected stuff following that. So it's not really a valid XPath expression. So this is an example of where building up some kind of expression using unknown input can lead you to have bad results. There's actually a type of malicious attack that you sometimes see on where people will attack web servers or web services or whatever by using what's called a SQL injection attack. And that means that maybe they're filling out some form on the web or something, and they put in SQL is it's not XPath, it's a different language, but it's a language for querying SQL databases, structured query language. SQL stands for structured query language. People will put in SQL commands and stuff so that when the web service uses their input from the form to construct a SQL query, they end up doing, the malicious attacker ends up causing that query to do things that the designer of this script did not want. So this is analogous to that. We have input that caused, that contains special characters that were interpreted not just as a string, but as really part of the query. So to guard against that, there are a couple things we can do. So first of all, the problem here was that we had a single quotation mark in the string, and in the query, the single quotation mark was used to delimit the string, to mark the beginning and the end of the string. So here I will open a slight variant of this script in which instead of using single quotation marks, I've used double quotation marks. So now, of course, we have double quotation marks enclosing the whole thing. So in PowerShell, I can escape these double quotation marks by doubling them. So this is a literal quotation mark on line 11 and a little before the title, and a literal quotation mark after the title. And then within that we insert the string. So now the single quotation mark is not going to be a problem because the string is enclosed in double quotation marks. XPath allows single and double quotation marks to be used interchangeably, but if you allows the string to be enclosed in either. So that guards against that particular case. But now what if you had a string that included double quotation marks? Well, that would give us the same problem. So we sanitize the input by replacing any double quotation marks with single quotation marks. So basically we're saying in this data, or in this in this, in our data, we expect to find single quotation marks, but we don't allow double quotation marks. Or when we do find them, for example, if somebody maliciously typed in a double quotation mark, we're going to just replace them with single quotation marks. And when we run this, and we say the title is Harry Potter and the Sorcerer's then we see that that gives a valid result. There are two in our XML. We actually have two books with that title. One of them a hardcover and one of them a paperback, but both with that title. And so we actually get two outputs from that: the hardcover price and the paperback price. But anyway, it gave a valid result in this case because the single quotation mark was no longer a problem when it was part of a string that was delimited by double quotation marks. And if we try to get nasty by using a double quotation mark instead, let's go ahead and, well, actually let's just do it like this. Let's go ahead and put in a double quotation mark here, and of course we have to double it in order to have it treated as a literal quotation mark. Then at the end of our query, we have sanitized that input by converting the double quotation mark to a single quotation mark, which is what we see in our query string, and so again, it's not a problem. Now, there isn't really a general purpose way that I know of in XPath to escape special characters, unfortunately. I think there are complicated ways of working around this, but generally with XPath, you just kind of have to be aware that if you're dealing with user input or unknown input, you may have to guard against special characters that would cause your query to go haywire and do things you don't want. Okay, so one more thing I want to talk about with Select-Xml and with XPath, and that is how to deal with XML namespaces. So we first of all have to learn what XML namespaces are. So far we've been looking at this bookstore XML file, and each of these XML elements just has a simple name that's just a word. But XML allows, kind of like in the .NET framework, classes have their basic class name, but they can be grouped into namespaces. Well, XML allows elements to be put in namespaces, and those namespaces are represented by URIs, which is like a web URL, a uniform resource identifier. Now, the URI doesn't necessarily have to point to an actual resource that you can download or anything like that. It is really just meant to be a unique identifier to distinguish your namespace from anybody else's namespace. So here I have a different version of my XML file that is exactly the same as the first one, except that we have this additional attribute on the root element, XMLNS. So XMLNS is a special attribute that is part of the XML specification, and it means that the current element and any elements descended from it or contained within it by default have this namespace URI. So every element then has both a local name and a namespace URI, and kind of the identity of that element is the combination of the two. So you can't just refer to this element as bookstore, it has to be bookstore in this namespace. And for the namespace URI, I just picked a made-up URL, and like I said, it doesn't have to actually exist, it just has to be unique. So having a URL is a way of allowing you to specify something unique. This particular URL probably is not unique. For all I know, there is a mybookstore.com. I did not check. Anyway, so bookstore has this namespace. Book also has this namespace because it's contained within bookstore, and we did not change the namespace or override the namespace, and so on for every other element in this file. So if I were to go back to my the script I just had here, where I was querying the data.xml file, and I changed this now to data2.xml, then if I run this, we need to get back to if I just run it here, and I specify the 2 towers, then we did not find any output. So we output our query, but we did not find anything matching. And the reason we didn't find anything matching was because we were just looking for those elements. Because we didn't match those nodes. Like when we looked for bookstore, we didn't find it because we weren't looking for bookstore in the expected namespace. One reason, by the way, that namespaces are used in XML is just to be is to allow, you can actually mix elements of different namespaces in the same file, and so you can include sort of foreign data in your XML file that may have some of the same element names, but they won't collide with your element names because they're in a different namespace. Anyway, so how do we address this? Well, here's a different version of our script. This is exactly the same as the previous one, except that we have added namespace support, and this is done in two steps. First of all, we need a way of referring to the namespaces in our query, and what we've done here is we've defined a hash table that maps namespace prefixes to namespace URIs. So here we've created a hash table. We've assigned the variable ns to a hash table. So we've used the @ curly brace notation to construct a hash table. And inside the hash table, we've added one entry or one element, which maps the string B to the string https mybookstore.com inventory, which is the namespace URI we specified in our XML file. So here's our XML file, and here is our hash table. So B, the B prefix, now refers to that namespace. And then the other stuff is the same, but when we construct our query, each of these element names is preceded by B:. So that means that B:bookstore refers to bookstore in that namespace. B:book refers to book in that namespace. The attributes do not have namespaces. You can have namespaces on attributes, but that doesn't just happen by default when we put an XMLNS attribute here. It doesn't cause the attributes of elements under it to be grouped into namespaces. And again, B inventory is referring to inventory in that namespace, and so on. So if we run this script, test XPath 5, title the 2 towers, then we get the results we expect. So one more thing is that here's our XML file where we use the XMLNS attribute. It is also possible to use namespace prefixes explicitly in the XML. So if we have, here's another variation on the file. In this case, instead of using XMLNS equals and then a string, we said XMLNS:B is equal to this namespace URI. And what that does is we haven't changed what the default namespace is of each element. We've just said that the B prefix is now associated with that URI. And then for each element, we can then specify what its namespace URI is by preceding its name with the namespace prefix. So this is actually quite similar to how we refer to these elements in XPath. So that's just really equivalent to the other one. It just means that we're making the namespaces explicit. And that is, again, how if we wanted to mix different namespaces in the same file, using namespace prefixes is a convenient way to do that. So if we go back to our script that we were just looking at, and we process data3.xml instead of data2.xml, we see that the two files are really equivalent, because if we run that script, we get the same output. One more usage of Select-Xml to show you, building on the last one. And again, we have a title parameter, and we have the namespace, and we have our data that we read into memory and parse and construct an XML document from it. We construct a query. In this case, we're just querying for our XPath query is a little different because we match the book element, a book element with the specified title, but we're not grabbing the inventory. We're not then going from there down to the inventory and price element. We're now just matching the book element. Now we do our Select-Xml query, again specifying the namespace. I'm not sure if I remember to specify before that you have to include the namespace parameter, which is this hash table, in order for the namespace prefixes in our query string to be resolved. Okay, so that's part of how the namespace parameter is a hash table used with Select-Xml whenever you have to refer to namespaces. Okay, so anyway, we select our XML. This should then match the book element with the desired title. And then we use we pipe the output of that to our for each object commandlet. So this code block, this script block inside the curly braces will now execute once for each matching book element. Or really the pipeline variable $_ is going to be the select XML info object that corresponds to a matching book element. So then what we want to do is we want to produce output that includes the title, the format, and the price for that given book. So to get the format, we take the pipeline variable, we grab the node, which is an XML element, and then the XML element has an attributes property, which we can then, which is a collection of XML attributes. We can refer to the format attribute using the square brackets. So just like we're indexing into an array or a hash table. And then that gives us back an XML attribute object. We get its value, which is a string, and then that is the value of the format attribute, which we store in a variable. So the format variable now is the format of that book. For price, we're doing something a little bit more complicated. We are actually using a nested Select-Xml command. The XML in this case is actually the matching node that we got back. So we have $_ is the Select-Xml info. The node is the book element, the matching book element. So we're using that as the XML. We're actually, instead of the entire document being the input to the Select-XML, it's a specific node within the document. So this is using Select-XML to query from a given node in the document instead of querying from the root of the document. Now the XPath we're using, we use the dot symbol to mean the current, to match the current node. So we're going to be constructing a relative path from the current node down to a child inventory element, and then we're going to get its price attribute. And again, we have to specify the namespace hash table because otherwise the b : doesn't mean anything. So the b : will match the namespace URI because we constructed a hash table that mapped on line 7 that mapped b, the b namespace prefix to that namespace URI. And again, so we get back from that Select-XML, we should get back an XML attribute, or excuse me, a Select-XML info. Its node property will be the XML attribute, and the value will be the actual price. So finally, we write the output, which consists of the title, format, and price. So if we run this script, we'll say test XPath 6, and we'll say title, the 2 towers. And we see that 2 towers, paperback, $7.99. And if we say title, Harry Potter and the Sorcerer's Stone, if I can type, then we see that there are 2 matching books, and the first one has the title we see, hardcover, $19.99, and the second one is the same title but with paperback as the format and $9.99 as the price. So this script demonstrates how we can actually use Select-XML to query not just from the root of the document, but we can use a nested Select-XML query to query from anywhere in the document and use a relative XPath. Okay, to recap, we talked about what XML is. It's a text-based document format that gives us a structured, that can be converted, it's a hierarchically structured data that can be converted into a tree of XML nodes, which is what we can call an XML document object model. And we've gone through a bunch of examples of using the Select-XML commandlet to query that tree using XPath, where XPath is a way of selecting nodes within that XML tree, just like a file path would be a way of selecting folders or files within a file system tree. So in our examples, we looked at some very basic XPath. We also added predicates to be able to select elements that have desired attributes. We looked at dealing with user input and making sure that that input doesn't blow up your query. We looked at namespaces, where you have to have a hash table that maps prefixes to namespace URIs. And we looked at an example at the end in which we have an XPath query that is run on the result of a previous XPath query. So we call that nested queries. So that is summarizes using Select-Xml to query XML in PowerShell. In a future video, I hope to talk about other ways of processing XML using the .NET XML Reader and XML Writer classes. I hope this is helpful. Thank you. Bye.